Welcome back everyone. In the previous couple of sessions we talked about k-means and we utilized two methods so far that we talked about to identify the ideal number of clusters. So we looked at the elbow method and we also looked at the silhouette. In this session we're going to talk about the mean shift. Now I'm going to avoid talking about the mathematics with this. I think it's not worth dwelling into it, but if you really want to, I would encourage you to actually make use of the Wikipedia. There is actually a link that I'm going to provide you right now, so that you can actually dig into it if you want to. So let me just Wikipedia. Right, on mean shift. Okay. Couple of basic things I still want to cover is that the basic general intuition is non-parametric. Literally means that it doesn't assume the underlying so-called distribution. The other thing is that it identified the actual centroid location. Now this is basically how it works. For each data point, it identifies a window around it. And then the next thing it does is that it computes a centroid. And then it updates the actual centroid location, and then it continues to update the windows. It keeps shifting the centroids, the means, towards the peaks of each clusters. Hence this term here called means shift. It keeps shifting the actual mean of the so-called of the centroid. Essentially, as you add points, it shifts the mean. So it continues until the actual centroids no longer moves. It's quite commonly used for object tracking and is quite a powerful method that we will see. So that's pretty much all the description I'm going to provide for mean shift. That's sufficient, I think, rather than going into the maths of it. So let's dig into the code and see how we can actually utilize this to identify the clustering issues that we do have. So from scikit-learn cluster library, we're going to import mean shift. Mean shift and also estimate the actual bandwidth itself. And the next thing is that we're going to, from the iter tools, we're going to import cycle. Right, bandwidth. X is equal to the estimate bandwidth, and X quantile is equal to 0.1, and number of samples is equal to the length of X itself. Right, estimate quantile Z is not defined, X, not Z. Okay, having done that, what we're going to do next is that we're going to look at our mean shift model. This is equal to mean shift, and the bandwidth is equal to bandwidth X that we estimated, and the bin seeding is equal to true. And after that, we're going to use our mean shift model and fit the X to it. Alright, so the cluster centers is equal to mean shift model cluster centers. Okay, so let's just print these clusters and have a look at where they are. So print /n, this new line, centers of clusters. New line again, and just comma, cluster center. Okay, so those are the actual center of the cluster itself. Right, what we want to do now is just create a labels, and the number of clusters is equal to the length of the unique labels that we get. Labels. So if we have, in this case, 1, 2, 3, 4, 5, we have 5. That means the length is 5 here, so the number of clusters estimated is actually 5. So what we're just actually going to print here is new line again, number of clusters in input data is equal to, and comma, number of clusters. Right, so here we go. It says number of clusters in input data is 5. So what we're going to do next is plot, visualize this plot the figure, and we're going to use a couple of markers. Just the usual, we're going to use the asterisk, V, O, S, and then X. Alright, so that's our typical markers. So for I marker, in zip, the range of number of clusters as well as the markers, and now we're going to plot the scatter diagram of this. X, when the labels is equal to I 0, close this, X, and the labels I again. This is basically what we're doing here is that we are okay, so basically we're plotting the X and the Y, and the next thing is that the marker to denote the marker, and then the color is going to set to be orange. Okay, the next thing is that we do want to plot the cluster center. So this is really plotting the actual blobs that we have earlier, and we're going to now locate the cluster center, I, and plot them, cluster center, and also the cluster center. Okay, cluster center. Okay, and now so because we are iterative through this, so it's quite easy to actually take all of these. In essence, what we have is basically we are plotting iterative through. We have the number of cluster is basically, this will be 5, so it will iterate through 0, 1, 2, 3, 4, 5, and then the markers is actually these markers that we actually set here, 1, 2, 3, 4, 5. Okay, now let's see. Okay, let's for the sake of we do need to actually add a few things. So the marker, face, color, let's just set that as black, and that's K, and the marker, the actual edge color, we're also going to set it as black, and finally the marker size is equal to 15. Okay, right, having done all this, so let's just plot the title, and we're going to close this the clusters. Alright, okay, cluster center is not defined. Let's just have a look. What do we actually define? A number of clusters, cluster center. Let's have a look. Cluster center, not centers. So we actually have a typo here. I think I just called it centers. Centers. Right. Okay, we have another error here. What is the error? Well, it came through okay, no issue at all. So let me just squelch this line. I don't want to see this line here. All right, what do you see here? Now let me see if I can change the fixed size a bit. 10:8. Okay, that's a bit larger. All right, so we can actually see that these are the so-called different marker that we use that we actually specify here. Now, what do you see? You can see that the actual centroid actually sits in the middle of the actual different cluster itself. That's the first thing. The second thing that you do note is that it actually identifies exactly 5 clusters. That really identifies the strength of this algorithm in that its ability, number 1, to identify the number of clusters. Number 2, its ability to locate the actual centroid of these clusters. And that's comparing the 3 different methods that we have. You have the k-means, which you actually have to specify yourself and try to locate. The k-means using the elbow method, whereby you actually need to identify the number of so-called centroid yourself, or cluster yourself, sorry. And the second one is you use the silhouette to try to estimate. And then the third of all of these that actually works really well in this case, and in this case, is actually the min shift. So these are the three different methods that we've used to actually identify the different clusters. Now, why three different methods? The basic idea is this. Because we're working with data that doesn't actually have a target or a label, we really don't know what is the actual ideal answer here or ideal solution here. So hence we do need to use various methods to confirm each other and try to investigate those that actually say otherwise, to see is there some sort of pattern, underlying pattern that we need to actually investigate a little bit further. With that, I end this lesson. I hope that you found it useful. And in the next lesson, we're going to apply all of these things that we've learned into a real world data or a real world scenario. I look forward to speaking with you then.